So good afternoon everyone. We are going to discuss about electrical transducer in this video. Okay, it comes in the measurement system module, the fourth module. Okay, so first we are going to discuss about the electrical transducer. So normally the electrical transducer, it will be act as a secondary transducer. Okay, and it will be converts the one form of energy into the another form of energy, like mechanical energy into the electrical energy, so that it will be act as a secondary transducer. Okay, so in the electrical form, it will be shown as a current as well as resistance or voltage. So example for this electrical transducer is the linear variable differential transducer. Okay, so in the linear variable differential transducer, this may uh, the converts the mechanical displacement into the electrical signal. Okay, so this transducer, it may have resistive, inductive or capacitive type. Okay, so advantages of this electrical transducer is the so it will be very small in size, as well as the frictional inertia effects are mainly it will be reduced over here compared to mechanical transducer, and remote recording and control is possible, and amplification and attenuation signals may be easily obtained. Normally amplification will be comparatively high. Suppose if you are compared to mechanical transducer, and here it will be used to less power consumption, and signal output may be easily processed and transmitted. Okay, so this is about the advantages of electrical transducer. Mainly here the output value we can see clearly only because of digital value we are going to see clearly. Then disadvantages is that the accuracy is very less, and cost of the machine, it will be more compared to other things, and increased circuit complexity. Suppose the circuit, so normally the circuit, it will be in the complex manner, and comes into the next is that it require more space, and although already we discussed about the circuitry cost, it will be more, automatically the this component cost also it will be more. So these are all the disadvantages. Then comes into the resistive transducer. So resistive transducer, we are going to calculate with the help of the relation R is equal to rho L by A. So here R is the resistance in ohms, rho is the resistivity of the material in ohm, L is the length of the conductor in centimeter, A is cross sectional area. Okay, so this resistive transducer is also called it as variable transducer. So this mostly commonly used type is this variable transducers. So that it can measure the physical quantities like temperature, pressure, displacement and vibration, etc. So this transducer will be the secondary transducer. So in this secondary transducer, so in the resistive type transducer, first we are going to discuss about the sliding contact devices. Okay, so in the sliding contact devices, it is going to convert the mechanical displacement into the either current or voltage input. Okay, and output achieved by changing the effective length of the conductor. The slide or contactor maintains electrical contact with the element, and the slide is measured the linear displacement of the slide. Such devices are used for sensing the relatively large displacement. So here it can be going to measure with large displacement also. Okay, because of it using the sliding contact. Okay, then comes into the next thing, potential. So this potentiometers elements may be formed by wrapping the resistance wire around the shown in figure. So in this, the effective resistance between either end of the resistance element and the slide is measure of angular displacement of the slide. Okay, so this is about the potentiometer. Then comes into the variable self-induction transducer and variable mutual inductance. Okay, so it have a single coil as well as two coil. So coming to the variable single coil element. So here the mechanical input changes premiums of the flux path generated by the coil. Okay, and this change is inductance can be measured by suitable circuit. Measured by suitable circuit indicating the value of the input. The flux path may be changed the air gap. However, the change either amount of type of core material also be used over here. Okay, so this is here the air gap. So the amount of change of air gap it will be changed. Okay, so due to the flux. Okay, so this is about the variable self-induction transducer. Then comes into the this one mutual induction. So when you come into the variable mutual induction coil method, okay, the flux from a power coil is coupled to a pickup coil which supplies the output over here. So then the input information in the form of armature displacement, the changes in the coupling between the coils. The air gap between the core and armature govern the degree of coupling. Okay, so here the detector portion electronic micrometer inductive coupling between the coils, which depends upon the performance of the magnetic flux path is changed in the relative position of the permeable material. Okay, a variation of this can be used transducer measuring small internal diameter. Okay, so for this variable mutual induction coil has to be used.